So till now we have seen and demonstrated practically about kubeconfig. So now we are going to talk about namespaces. So this is a Kubernetes object, a namespace. We are going to talk about namespaces, how you can group or isolate your resources, that we are going to look into. So namespaces is basically used to group or isolate your resources. So what is a namespace for us? A namespace is an object which isolate or which provides a mechanism for isolating groups of resources within a single cluster. Names of resources need to be unique within a namespace, but not across namespaces. Namespaces of resources which are there inside that the names of resources which are inside that namespace need to be unique within a namespace but not across namespaces. I hope you got that. Namespace based scoping is applicable only for the namespace objects, example deployments, services, etc., and not for cluster-wide objects such as storage class, nodes, persistent volumes. But the question arises when to use multiple namespaces. Namespaces are intended for use in environments with many users spread across multiple teams or projects. For clusters with a few to tens of users, you should need not to create or think about namespaces at all. Start using namespaces when you need features they provide. So namespaces provide a scope for names. Names of resources need to be unique within a namespace but not across namespaces. Namespaces cannot be tested, namespaces cannot be nested inside one another, and each Kubernetes resource can only be in one namespace. Namespaces are a way to divide cluster resources between multiple users. So it is not necessary to use multiple namespaces to separate slightly different resources such as different versions of the same software. For that, you have to use labels to distinguish resources within the same namespace. So normally you can create namespaces for development environment and production environment, and like this you can isolate your environments. For example, you have a dev environment, prod environment, testing environment, and staging environment. For each environment you can have a specific resources names, because every each environment you can make it as a namespace, and then each namespace can have a resources with different names. Like this you can isolate your environments. You can also create a different namespaces for different projects and for different themes. So now let's also look into some of the fundamental namespaces that we found inside inside the Docker. Inside the Kubernetes. A pod is similar to a set of containers with shared namespaces and shared file systems. So Kubernetes starts with 4 initial namespaces. So what are those? The first one is default second one is kube public, and third one is kube node lease. The fourth one is kube system. So what are those? That we are gonna directly jump into our server and we'll see. So let's get into our server. Yeah, this is local. Let me close this. Okay. Mm, done. Exit. Yeah. Clear? So Kubernetes cluster namespaces can be seen. The default one can be seen. So to see that, we have to say kubectl get ns or namespaces. Here it is. Either you can also say kubectl get ns. Either one works. But you can see here, so some of the initial namespaces that will be generated with your cluster are these. What are those? Default. The first one is default and active 138 minutes ago. It has been created because that time it was created. The COPS cluster has been created at that time. So all have been, these are the initial namespaces. Okay. So what is default? A default namespace in this Kubernetes includes this namespace so that you can start using your new cluster without first creating a namespace. That's what the default namespace. You don't need to create your own first namespace because the default is there for you. Then we have a kube node lease. This is the second initial namespace. A kube node lease. This namespace holds lease objects associated with each node. Node leases allow the kubelet. Kubelet is part of the working node. Okay, this node leases allow the kubelet to send heartbeats so that control plane can detect node failure. So this is how, okay, this is how your system, your control plane, your master node will check the health checkup from this using this namespace. And we have a third initial namespace that's called kube public. This namespace is readable by all clients, including those not authenticated. This namespace is mostly reserved for cluster usage in case that some resources should be visible and readable publicly throughout the whole cluster. So the public aspect of this namespace is only a convention, not a requirement. Then the fourth one is a kube system. A kube system, the namespace for objects created by Kubernetes system working with namespaces. So now we have seen initial namespaces. So we can create our own namespaces also. But before we create our own namespaces, we can also get the resources that are included in that namespace. For that, what I can do is I can also say we can show all the names in my default namespace. How can I do that? I can say kubectl, and when I say get all, by default it will bring all the resources names that are presented inside the default namespace. Okay, let me do that. You see that this is a default namespace. It's service /Kubernetes. by default. Okay, I did not create and you did not create and nobody else has created this. By default it was created, the name. And then type is cluster IP, and 142 minutes ago it's been born, and cluster IP is this. Okay, that's the default namespace. And we also can see all the resources from all the namespaces. If we want to do that, what we have to do is we have to say kubectl get all from all namespaces. Here it is. Oh, that's huge. Let me scroll up. Yeah, a lot of there are 4 namespaces and there are a lot of resources in that. Okay, yep. As we have discussed earlier, let me get into this slide also. So default kube public, and or else let me make it smaller this time so that I can give a comparison. Yeah, I think this works. Yep, no, it's fine. So the last one we have is a cube system. Okay, so it begins with the cube system itself. The cube system. This is a cube system namespace, and inside that you have a lot of names. One is pod AWS Cloud Controller Manager. Then we have a node EBS Elastic etcd. You see that etcd manager that basically stores the key value pairs, and cops. You see that cops controller. Even cops controller is also part of this. So the cops, the name, the cops instance that we have given now, so that is also part of this. It's part of cube system namespace. And cube API server, you see that cube API server is also part of this cube system namespace. And cube scheduler. So what I'll do is I'm going to show the exact picture of all those things so that it would be much clearer for you. Yeah, here it is. So I'm going to show you every component of this, every component, maximum every component. So this is our architecture, our cluster architecture. We have seen the API server, but now we're going to see again. So, yep. So cube scheduler, here it is, scheduler. So this is the pod, again a scheduler, cube scheduler pod. And cube proxy, I'm going to show it. The working node will consist of a cube proxies, and here is that cube proxy. How many cube proxies we have? 1, 2, 3, and this belongs to this cube proxy. Cube proxy, okay. Then we have cube controller manager. I'm going to show that also. Here it is. Controller manager. Controller manager. Then we have API server. Here it is. Here is that API server. Then COPS controller. This is main COPS controller. For that I have to get into EC2 instances, and here is that our COPS. COPS. Okay. Then etcd manager. etcd manager. And that's here. etcd. etcd manager. Then we have other information also, but I hope I have shown you most of the things now. And that's our cube system namespace. These are the names that are present inside that cube system. Now another namespace is default namespace. Inside that we have only service Kubernetes, and then cube system with TCP, it has a service kube DNS. Then another name, cube system, it consists of AWS Cloud Controller Manager and COPS controller, and EBS. Yes, this is all about our namespace, that all namespaces and all the resources which are present inside that. So now if we want to see the resources from the specific namespace, only specific namespace we can give. For example, I want to see from the cube system because we have seen, but again we'll see that here is that cube system. So for that, all I'm gonna do is kubectl get its svc and namespace n option, and that is cube system, and here it is. So specifically, a cube system namespace consists of cube DNS, a cluster IP with this one, and UDP, TCP, and one more protocol it's following. This 53 port, and 9153 port, and this is part of cube system namespace, and this is the name of that resource. Cube DNS is a resource, cube system is a namespace, and cube DNS is the name of that resource. Okay, so now let's look into the more. So we have viewed the namespaces using kubectl get namespace. Now we will create a new namespace. Let's do that, and then we will delete the new namespace. This exercises we are going to do. For that, again we have to get into our server, our cops. We are in cops instance. So clear the screen and make it bigger. It's fine, I guess. So now let's create our first namespace. So what I'm gonna say is, to create our first namespace, I'll say kubectl create ns, that's a namespace, and namespace, I'm gonna name of the namespace is cube first ns. This cube first namespace, that is the name of the namespace. Now let me click execute. That's it, the namespace cube first ns has been created. So now what we're going to do is, we will create a first pod, and then we will attach that pod. Pod itself is a resource, right? And this resource name we will be attaching with the cube first ns namespace. That's what is our activity. So activity is to create a nginx pod and attach this nginx pod resource with cube first ns namespace. Okay, done. So let's do that now. So let me create a pod, sample pod vim. The name I'm gonna give is pod1.ml. So let's start writing this. We'll begin with API, API version, it is v1. Then kind, what type of object you want to use. I'm gonna use pod capital P. Then metadata should be entered now. Metadata. So inside that metadata, okay, that's the issue here again. Okay, it doesn't work. So we'll face some issue with I'm gonna open Visual Studio Code. Yeah, this somewhere. I'll create this is my namespace directory. So here I'm gonna open Visual Studio Code. and so pod 1.ml. Okay, let's begin. So first one is API version. That's a v1. Then we have kind. Kind is pod. Okay, we got the sample. So I'm gonna keep this pod is fine. Okay, let me remove this first. Yeah, rest all is okay. So kind is pod. Then metadata name I'm gonna give nginx 1. And labels I'm not going to use that labels now, because now we are dealing with the namespace, so I'm removing these labels. Then spec containers. So container, you bring the container, you run a container from nginx image. You run a container inside a nginx pod, and then image name I'm gonna give nginx latest. That would be fine. Nginx latest. Yes. And ports resources, let me remove this, it's not required at this moment. Yeah, one more. Yep. So ports. So container port I'm gonna take at 80. Okay, name is wrong because it's nginx 1 that we have attached here. So name of the pod nginx. So spec containers and name image ports container port. I think this is the issue. Yeah, that's okay. Let's see. Okay, okay. This is one more problem. Port 80. That's done. There is something wrong here. I think let's see. That's fine. Rest all is okay. So let me save this and copy this and come to our cops and paste it here. I hope it's fine. Let's see. Latest is also okay. Yep, it's done. Now we have mentioned that's our actual pod. So now in this pod we have to mention the namespace. We forgot to mention the namespace. Okay, let me mention that, or else we'll do that here only. Yeah, so namespace comes inside the metadata after nginx 1. Yeah, here the namespace comes. Let's say namespace and the cube first ns. That's what the namespace, and wq. That's it. So our definition file to create our first name or to attach a resource to the namespace is ready. Now it's time to create the pod. So to create a pod, so we have to type kubectl and apply an F option, and the name of the file is pod1.ml. Let's execute it. Pod nginx1. The name of the resource is nginx1 is created. What type of object it is? It is pod type, because that's what the kind we have given there. So now let's fetch the pods from the cube first ns. Let's see what all there inside that. Kubectl get pod And option N, that's a namespace. And after that, we are going to give our namespace. That's a cube first ns. That's it. Your Nginx is up and running. You see that? It's running. There are no restarts. It's running. And again, you can give kubectl get ns, and you should see your namespace here. Just 7 minutes ago we have created, and this is the namespace that I have created. You should also have created this namespace 7 minutes ago if you are following my video. So cube first ns, it's been done. Now it's time to delete the namespace. To delete the namespace, I can simply say kubectl and delete, and ns namespace is cube first ns. So namespace cube first ns has been deleted, and it's waiting for something else. We can see that it's deleted. Now let me give kubectl get ns. That's it. There is no cube first ns. The namespace has been deleted. Kubectl get node. Okay, so at this moment we have 3 nodes, and I will say pod no resources found in default namespace. Of course, we have specifically attached a namespace, and that namespace was deleted, so at this moment there are no pods. By default, when you say kubectl get pod, it will basically bring that pod, it will search for that pod inside the default namespace, not anywhere else. If you want to specifically get a pod from certain namespace, then you have to say kubectl get pod, pod, and then you have to mention the name and the namespace. So cube first ns, of course it's been deleted. It will say no resources found in cube first ns namespace. Of course there is no such namespace, also it's been deleted. But that's how it works. That's how basically you can create a clusters, or you can create a namespaces inside that. You can group your pods, group your resources into certain you can group your resources into certain sections. Okay, that's how you can isolate your resources using namespaces by grouping together.